Programming Throwdown, Episode 91, Functional Programming, Part 2. Take it away, Jason.
Hey everyone, so we got a lot of feedback on our interview with Jonas Bonner a few months back, and a lot of you really wanted to know more about functional programming and really dive deep. And I'm really excited that we have Adam Bell, engineering manager and podcaster. He's been an engineer for about 15 years. He's done a lot of functional programming in his career. And we're going to sit down and have a chat about functional programming, about Scala, about a lot of these different concepts, and really kind of dive deep, start from the basics, and get people kind of ramped up onto functional programming. So welcome to the show, Adam.
Yeah, I'm glad to be here.
Cool. Yeah, so what is functional programming?
So at its simplest level, it just means that you would construct programs only using pure functions. And a pure function would be something that, like a function in the mathematical sense. So it takes in inputs and it produces outputs and nothing else. So that means, no modifying of global state, no, modifying data structures in place, no throwing exceptions. And maybe the more tricky requirement is no reading of user input, no writing of things into the outside world. Mm-hmm. So that is kind of a high level of what pure functional programming is.
Yeah, that makes sense. I think one of the things that I always found really tricky was exactly what you said. I mean, at the end of the day, a program is going to interact with its environment. That could be reading from a file, that could be writing to the network buffer or something like that. And I found that to be one of the hardest things to grasp when you join it with functional programming. So it's sort of like, how do you a file is kind of inherently stateful, and it seems very natural to have this global file because you only have one of these files on your hard drive, right? And how do you get people from thinking in that way where they just have all of these globals for all of these environmental things that are literally global? How do you get them from that mindset to this functional mindset?
Yeah, I mean, I think you can think of it as a design constraint that you place upon yourself. So I think a common pattern you might see is having a very functional core of your program and then kind of an imperative shell around it. So if you have the file as you're saying, and you need to do a lot of transformations on it, you may have functions that are ostensibly pure that take in lines of that file and do some sort of transformation. So they meet the definition, but somewhere at the outside you have some imperative layer that does the actual I/O. And I think that it's a really useful design constraint, because what you end up with if you limit that imperative side effecty stateful code to the edges is a system that's very testable. Like all the parts except that imperative stuff can be tested quite easily. They just have, for this defined output, do I get this? For this defined input, do I get this defined output? And so testing is easy. Reasoning can be a lot easier in that world where you're kind of pushing towards functions. So I think that it's a challenge, but it's certainly one that has a lot of value, in my opinion.
Yeah, that's actually a really good way of looking at it. I think when I started working in industry, if you can actually go and look at my PhD code, I'm not proud of it at all, but it didn't really have any tests or anything like that, because you're just kind of writing it by yourself. And so one of the real challenges when I got into more of an industry role was kind of realizing that, we have to really write tests because we're really there's other people who are sort of depending on our code to behave in a certain way. We can't really use a lot of our own intuitions and spread those like through osmosis to the rest of the team. And sometimes you find that after you've written something, you go to test it and you realize it's impossible. It can't be tested. The only thing you could do is just test main, right?
Yeah.
And then you say, I have to modularize this. I have to break this down. And while you're doing that, you say, okay, I'm going to pull this function out and test it in isolation. But to do that, it needs to be context free, right? If you go to test that file, that function, and it calls a global and crashes, you say, oh, okay, now I need to take that global and pass it into the function so that I could pass in, a dummy or something, a dummy object. And what you're doing is basically you're learning functional programming. So I think, a good way to get started, if you've been going through some tutorials, you're learning how to program, and you feel pretty proficient at procedural language, maybe C, C++, Java. I think testing your code, even if you might be the only person who will ever use it, testing it will be a really good exercise in software architecture. And along the way, you'll be forced to discover functional programming in one way, shape, or form.
Yeah, no, I totally agree. And I think that it's been thrown at me before, like this statement, hey, if your code isn't easy to test, then it's not good code. So people, especially like people who are really keen on test-driven development, will say this. But the problem I have with this statement is like it doesn't really tell you what to do, right? It's just saying like, hey, this code is bad. So I think that some of these functional principles can guide you in that direction to say like, no, I mean, you can even have things that are well tested that just aren't good code because you have like crazy mocks and stub services and whatever.
It's all pound defines, compiler macros.
Yeah, exactly. So, I mean, to think about things as being pure functions as much as you can, I think really guides you in the right direction. Yeah,
that totally makes sense. So what are the functional programming languages that you use the most?
So I spend my time in my day job writing Scala, which is kind of, I guess, a multi-paradigm language. It supports like, Java style object-oriented stuff as well as functional programming. And so that's where I spend most of my time. Huge fan of the language. And then, I also am guilty of playing with a lot of other languages. So I spent time teaching myself Haskell, and that was certainly a great experience. And
definitely. We had a lot of Haskell at a place I used to work, and it's interesting. I actually really enjoyed it, but part of the challenge was we were building a software library for other people to use at the company, and so what that meant is anyone who wanted to use this library had to learn Haskell. We found that to be really difficult, and so we ended up having to rewrite the whole thing in Python. Which is pretty sad because it looked pretty elegant in Haskell, but this is just the way of the world. Yeah,
I think that like Scala maybe is because it is multi-paradigm. It can be used as sort of a better Java, and so that maybe makes it more palatable. And also like if you were building a library, like in your specific case, like there's nothing saying you couldn't use that from any other JVM language. So there's some benefits there. I mean, the trade-offs are like, Haskell is a very hard line. This is a pure functional programming language. There's no, or very few like escape hatches, I guess. Whereas, if you're trying to apply an FP style in a language that doesn't enforce it, I think that requires, like obviously if the language isn't enforcing it, then that's kind of up to the team to say this is a goal,
Yeah, exactly. I think if you're building a service, you can get away with it because you can write a protocol but if you're building a library, then the lesson I learned from that experience is or really, I guess I wasn't the tech lead at the time, but the lesson the tech lead learned is to really know their audience. I think that's kind of a universal truism. So you said you're doing Scala. So as you said, I've seen Scala applied in many different ways. So it's used in Spark, which is this big data compute platform. There's the Play framework, which is kind of a web service. Are you using any of those, or what are you? What's sort of the scaffolding you're using on top of Scala?
So we have one project that is a Play project, but it's more of our legacy product. So we're building, I guess, web services, and the main library that we're using is called HTTP4S, and it kind of is very much in the paradigm of using Scala to be for functional programming. And like it provides a really nice metaphor on top of working with a web service. So like if I'm writing code to respond to some route that returns like some user information that maybe gets aggregated from somewhere, in HTTP 4S with this kind of functional model, I have a function that gets in a data structure that represents a HTTP request, and then the thing I return at the end of the day is a data structure representing an HTTP response. So it kind of fits this function model: data in, data out.
That makes sense. What about contextual things like cookies? Are they in the request object?
Yeah, I mean, cookies do come in the request object. I don't think that violates the like you're still getting everything in you need, basically.
Yeah, that makes sense. So basically, the request is sort of this multiplexer, or this structure that has cookies as headers, probably then it also has the body with the actual, if it's a post request, it has the body. And then you can return some response that maybe has the status code and the body as well, or something like that.
Yeah, and then you may further subdivide this, right? Because you probably want to take some sort of structured data out of that request and return some structured data and have ways to format it. But at the high level, it's a very simple metaphor. A long time ago, I worked in ASP.NET, and they had this like page lifecycle model, and I remember like, I wanted to return that, the status code was whatever, 409 or something, and you write the code to return it, but in fact, like behind the scenes, there's some page lifecycle, and it's already returned a response code where you are at, right? So you had to understand this, like, oh, it's not just that I'm writing the things that return the body. There's this lifecycle that lives outside of my code.
Geez.
And so that's very confusing. And I mean, most web frameworks don't work this way nowadays, but I think it shows how like this functional model where you kind of get in all your inputs and then get out all your outputs is much simpler than something where there's some sort of, extraneous information, like in this case that the header is sent, by overloading some other method in the framework or et cetera.
Yep. That totally makes sense. I think, a lot of people might say, well, you could do functional programming in any language. And, ostensibly that's true. I mean, you could fit the paradigm. It might not look that pretty. So in the case of Java, all of your functions would have to be objects that contain one method. But it's doable. But the nice thing about a functional language is that, as you said, it might not completely restrict you, but it makes it very easy to write functional programming, and it makes it more difficult to write this sort of the procedural programming where or just pure like recipe-based programming where you have all just global variables. And so it's like you can do almost anything in almost any language, but it's really, it's almost like being an artist, right? I mean, you could paint almost anything with any paintbrush if you had the dexterity, but certain paintbrushes will make it very easy for you to do certain strokes. And so like any art, certain languages and certain frameworks will make it very easy to craft your design in a certain way. And the functional programming way is extremely powerful when, as long as you aren't too dependent on, as I said, a lot of these environmental things. So a web service is a great example because effectively bits come in, bits go out, and the only thing you really have to interface with from a real world standpoint is the network card, but that's going through so many layers of abstraction that functional programming is a no-brainer there. I think a lot of this big data transformation logic is also a really good candidate for functional programming, which is why SQL and Scala now with Spark and a lot of these languages are functional because they really excel in these environments.
Yeah, and like with Spark and data processing, I think one reason it's a really good fit is just like if we talk about immutability, that you're kind of not changing the data in place, but kind of transforming it into a new format. That's very like easy to split up and distribute across machines and stuff.
Yep. How do you deal with things like databases, where database is this inherently sort of mutable object?
Yeah, I mean, so if you talk about, like you were talking about Haskell, and Haskell has like this concept of like IO, where they kind of wrap anything that has an effect in this IO type, and then instead of actually performing the action, right, the action is it's not actually run until the end of kind of until you fall off the end of main, right? It's kind of we're building up a program that doesn't get run until the very end of the world. And so that is a way, I don't know if that characterization makes sense, but that's kind of a way to encapsulate making changes to the outside world while still living in this kind of pure function world. And so what we do on our team is very similar. So we use like an effect type called CATS.io, I believe what it's called. So methods that perform an action upon the outside world, like instead of having something that goes out from a web service. Let me think of an example. So I call a web service and get back an integer, let's say, and then I need to use that in some further computation. So clearly there's some sort of interacting with the outside world there. Mm-hmm. So how we would handle that is we have this IO type. So instead of having this function that returns an integer, it returns like IO integer. And this is somewhat similar to kind of like the async await pattern that you see in a lot of languages. Yeah.
Or a promise, I guess.
Yeah. So the key thing is that it doesn't actually run until you tell it to run. So what we end up returning is like a promise that hasn't been started yet. And so you kind of compose these. Let's say we need to call out to a bunch of web services, like get an int from this one and feed that into this one, so on and so forth. So we return these IO wrappers and we compose them together to say like, okay, when this one's done running, feed that value into here. And it's very easy to compose. And then at the end of the world, like at the end of our request chain, we say, okay, now run this. And so that lets us kind of encapsulate the dealing with the outside world into this kind of into this type that we wrap the results in.
Yeah, that makes sense. Actually, one thing you mentioned, it's a really good point is functional programming, because each function is isolated, it lends itself really nicely to parallelism. So, for example, you might write a simple script. Maybe you write a simple Python script that does some text transformation, and you have this huge block of text. Maybe it's some comma separated value that you pulled out of this Excel spreadsheet you've been working on that has thousands of rows. And you want to do some transformation on on each line. If you just do Python, you could do it. It might not take that many lines of code. You just do a for loop for each line, do your replacement, right? But it's going to go through each line one at a time, right? But there's no reason it has to do that. You could have one process loading these lines from disk, and then another process writing them to disk, and both of them can be going as fast as possible. With Python, that's going to require setting up a thread pool. It'll probably have to be a multi-processing thread pool. You have to, create all of these, spawn off all of these tasks. You have to have a feature. You have to do a lot of work yourself, a lot of the heavy lifting. With a functional language, they've designed it so that they do a lot of that work for you. So for many of these languages, and now this is starting to make its way into a lot more than just functional programming languages. But yeah, this whole future, promise, async, await pattern, that really came out of functional programming. And for example, you can write something that solves a game search, like solves a checkers game or something like that in Lisp, and it will automatically use all of your cores. You don't have to be fuddling around with thread pools and all of that yourself.
Totally. It's interesting what you're saying about how this stuff is kind of feeding out into other languages. Because if you think about like, at some point, like Python having like map and filter and stuff was considered like that's functional programming, just because that was an idea kind of feeding out. And generics like having a list of T instead of array list. Like this is an idea that was called parametric morphism that originally came from Haskell and then was brought to Java. And like lambdas obviously are quite popular now. So I feel like there is a conveyor belt of taking these ideas and feeding them back to other languages because there is a lot of value in them.
Yeah, I mean, especially, a web server is a great example where you might have one person who maybe they're on their phone and they send you a request saying, hey, get me the weather. And your service tries to return the weather, but that person goes under a tunnel and now they have no reception. And so you're just pinging this person saying, hey, I have your weather, come get your weather. And if everyone else, maybe you have 100,000 users on this site, if they're all blocked because of that, your website it's not going to be functional, right? No pun intended. But, but that's where, again, a functional languages really shine because that actually could be really tricky to get right. Even if you have 8 threads, now you can support 8 people. If 8 people, lose reception, your website goes down. And if your website has thousands and thousands and thousands of people, it's not unreasonable. Functional languages are really, really good at they have these executors that sort of manage a lot of this. So if there's a function that's waiting on some hardware device or some I/O, that's okay. The language, the engine underneath the language knows to just put that one on hold, pick up a different one. And that's the kind of thing that can be really, really difficult to get right. So as we talk about a lot of these concepts making their way into other languages, keep in mind that there's a lot of advanced techniques in the functional languages that still make them really, really good for much better at doing these kind of tasks.
Yeah, totally. There was an example I remember from when I was learning this. That kind of made a lot of sense to me where somebody had like this, okay, here's like a service that processes coffee, like you're buying coffee. So it takes in like a credit card and then, it returns like something representing a cup of coffee. And then, in the body of this, it goes out and charges your credit card. It seems like a reasonable solution, right? And then but obviously it doesn't kind of meet this functional aspect we were talking about. So if you could transform it, so you take in the credit card and you return both a coffee cup and then something that kind of encapsulates this effect. So let's say it's just like a data structure that says, charge this card so much money. And then somewhere, obviously you have to apply this charge. But the interesting thing is if you start thinking about adapting this, now, what happens if, we say you make the one solution, I make the other, and then, requests come in, like we want to buy, a whole bunch of coffees, like we're going to buy 5 coffees. In the system where we're going out and like charging the card for every coffee that comes in, that's not what people expect when they buy a coffee. Where the system that kind of returns these charge objects, you could imagine just a process that kind of merges them before it actually sends off the request and is able to batch the effects, right? So this idea of making the effects, making the side effects you're going to do in the world like an explicit thing in the domain of your software. I think that's one of the kind of ideas, if that makes any sense.
Yeah, totally. I think this will also be revealed when people try to test things. So if you have, let's say you have some service that configures your router, and you try to test it. So if you have a unit test, which literally is going to go and configure your router, and you're going to run it hundreds of times and people will be running it with bugs, well, you're going to have a really bad router, right? I mean, that's a scary network to be on. So what you really want is to mock that out. And by not allowing, let's say, globals, for example, or by discouraging globals, you kind of force people to say, okay, this global router object that points to some driver that I got from Cisco, I can't rely on that always being there, or I can't rely on globals at all, let's say. So maybe the first step is let's pass that in. And well, as soon as I pass it in, now I could pass in something else, as long as it has the same signature. And that's kind of how people can, that's sort of how, like, I guess, well-tested or professional software works. What about in terms of typing? So, a lot of the early functional languages weren't typed. I mean, I'm thinking Lisp. I don't think Scheme is typed. They're all weakly typed. Now Scala is strongly typed. They have the type inference engine. Do you feel like there's what sort of side of the coin are you on?
I'm definitely on the side of types, and when I think about the value that I get out of this proposition I was saying earlier, like, a function takes some inputs and gets some outputs. A lot of the value I get is that the types kind of constrain what those inputs and outputs are. Mm-hmm. So I think types are super powerful, and like I think that functional programming in Scala, in Haskell, in more researchy languages, pushing the type system to be able to better encode the constraints of what you're doing is like a huge win in terms of software maintenance. So, like sorry, go ahead.
Oh, I definitely agree. Yeah, I mean, I've been burned so many times by weakly typed languages that I'm kind of done with that.
Yeah, and like if you look at like Scala or let's say Kotlin or even Rust or Swift, like one thing you're seeing is kind of using like a result type or an option type or something rather than like a null pointer. And like that, so that is another idea that's kind of, moving out into the ether of other languages from functional programming. And just that thing is so valuable, right? Just to say like, hey, you're not going to get a null pointer here. You have to explicitly handle, like if this is, possible, that this value is not defined, that's an explicit thing you need to handle.
Yeah, I think I agree with you. It's so useful. There was an issue the other day I saw at work where there's basically a function that was meant to return some information, and it didn't support null, and so we ended up getting a crash at some point saying that someone tried to pass in a null, and it turned out that there were some circumstances where that object that we were returning, it couldn't be retrieved. So I mean, think about like a double delete scenario where two people are trying to look up an item and delete it at exactly the same time, and the second process that arrives goes to get the item to delete it and it's not there, right? But because we explicitly ban nulls in this particular function, we got an error. Whereas in other languages, I mean, at worst, you return the null, you don't think it's going to be null, and then you start using it. And then you're lucky if the program crashes, like much further down the line. I mean, that's the best case scenario. It could even get worse than that. You just get corruption and things like that. So I think a lot of that stuff, and as you said earlier, it is making its way. Like now with C++ 17, there's the optional. Optional is now part of the language. So you could do optional foo equals bar, and then by default bar is null. But yeah, there isn't support for yet for I wonder if there's a way to, Patrick might know this, if there's a way in C++ to just blow up. I guess you could have an optional where if you tried to, actually I guess optional will do that. If you try to access it, it will kind of blow up. But
So in the new C++1, if you access an optional where the value is missing, it throws an exception by default. But there are ways you're supposed to check it before you do that, or say, give me this value or this default.
Yeah. So this is a common pattern. Like you'll see the same thing in Scala or Haskell or Swift, I assume. And I think that, go ahead.
Oh, I was just going to say, do you feel, actually you finish your thought because I have a kind of a tangent.
So I think so this is a great idea, and it ties in with kind of algebraic data types, which some languages are starting to get, and generally, FP languages have always had. But you can push these type ideas even further, right? Like the phrase that I think comes from like OCaml land is like make illegal states unrepresentable. Yeah, let's say it that way.
Okay.
And so to use the type system so that you can't that you could enforce invariance in your code using the type system, and having richer types allows you to do this more easily.
Can you give an example? Is it sort of like saying you can't do 3 plus dog or something like that? Is that where you're going with this?
So that's a super simple one, but so if you have some types, if you have a sum type, which is like a type that can be one of several values, right? So in Scala, I would have let's say I have like a sealed trait called animals, and then I have a dog, cat, and parakeet or something, right? And then somewhere else I have some code that does some pattern matching and pulls those apart and handles each case. And then if I add a new value called goat or something, the compiler will tell me, hey, you have not handled this case. This type has 4 possible values, and you are not handling that case.
I've seen that. Yeah, you're talking about the case classes. Is that the right word? The case classes in Scala?
Yeah, and so I think this concept of that's like totality checking, and some languages take it much further. But so when you're writing that, actually, I think that I'm trying to think of another example. Maybe I'll think of one. But yeah, using the type system to kind of make it more apparent when you are doing something wrong, I guess, is kind of the concept.
Hey, Jason, not to interrupt you, but before you go off on that tangent, do you want to take a minute to tell people about O'Reilly OSCon?
Oh, that's right. Yeah, OSCon is coming up. There's going to be a bunch of superstars there that you can listen to. They're going to talk about actually a lot more than open source software is going to be there. There's going to be blockchain. There's going to be AI. There's going to be cloud computing, distributed computing, be a bunch of different talks from people all over the world. You can go to oscon.com/PT for Programming Throwdown. If you go there, you can you'll get a special deal, which is really cool. Definitely check it out. There's going to be a lot of really interesting people. Do you know who else is signed up to speak?
So I actually would advise people to just go look at the website because there's a ton of people. But I know that there's Holden Crew from Google, Rupa Dashir from CodeChicks, Julian Simon from AWS, Allison Macaulay from Unblocked Future. I mean, the list is really big. Like I was starting to I'm going to read. Oh, wait, no, I'm not going to read all these people. There are a ton of talks. So actually, I've never been to a conference where I know we were talking about this last episode. And, you were talking about what it is kind of like to go to a conference. And I feel like going and talking to my boss about trying to be able to attend one, because I think it would be really cool to be surrounded by people talking about the kinds of things I'm super interested in.
Yeah, I mean, also one really interesting thing that this conference is doing that's pretty unique is they have sort of speed networking. They have book signings. They give you a really good opportunity to meet other people. I've been to conferences in the past where it was just very, very technical, and it was designed for you to go. It was designed for one-way communication, right? For you to go and listen to some talks. But this is really designed for you to interact and meet other professionals, which is really cool. So definitely check it out. You can get 25% off your pass if you use the code PT25. I believe if you use the link oscon.com/PT, you'll also get the discount, but put the code in just in case. And hope to see you there. Yeah. So with all of these languages, adopting a lot of these principles from functional programming, where do you see the whole ecosystem going? Like, do you see some of these languages sort of collapsing together? Or do you see there's maybe going to be, sort of an explosion of new ideas? I always kind of wonder if there'd be some type of contraction because a lot of the features will just, things will just become homogeneous over time.
Yeah, I don't know. I don't see it becoming more homogeneous. Like I only see it becoming more heterogeneous, I guess. Like just like the number of people developing software continues to grow. And like I don't know if this has to do with functional programming at all, but like as you were saying before, like if you're writing a service that other people are calling in some sort of grander architecture, like you could write it in whatever language you want as long as you agree on the protocol. So we're in some ways we're in like the Cambrian explosion of languages, and I mean I don't see that going away. Certainly the table stakes are higher for a new programming language, right? Like you can't just write like a compiler. People expect package managers and they expect like code linters.
Really good point.
Yeah.
Is there, I guess Scala has SBT, right? For the package management?
Yes. Yeah.
Yeah, there's still not a good, Patrick, you could correct me if I'm wrong here, but I don't think there's a good package manager for C++. Nope. I know there's Hunter, but it's not even that popular.
There are a few, but they don't. I've never found one that had enough critical mass of packages to be useful.
Yep, exactly. Yeah, there's Conan. There's actually one from Microsoft. I think it's like VC. I don't remember, but yeah, you're right. None of them can really get everyone on board. I mean, it seems like I can understand. I mean, it sounds incredibly difficult.
I think like maybe you guys disagree or something, but like, so C++ just existed before the idea that like languages should have a package manager, like was an important idea, right? And I think that there's these stops along the road, right? Like I think Go kind of put down its feet on like having a way to format your code easily, and that like languages, after Go are all going to have that. Like it's such a good idea, but languages before that, people are too busy fighting in their PRs about whether you should format it this way or that way.
Yeah,
like,
that's right. Yep. Yeah, I wonder. I really wonder what's going to happen. I do think that, okay, so to your point with Docker, with services, sort of service-oriented architecture, that really gives people flexibility to write any language they want. But I feel like the system is inherently winner-take-all as well. And again, I think there's always going to be a lot of languages. I just wonder whether the distribution concentration will just favor a few languages. Like I think Python, we do mostly Python at where I work now. We use the typing module and all of that. But yeah, I mean there's definitely better languages. But I feel like there's this sort of winner take all effect. Although to sort of play devil's advocate against that, TensorFlow recently added support for Swift. And so that I think is a game changer for a lot of people, doing machine learning and people in AI.
Yeah. I had on my podcast, Brian Cantrell, and he did this great presentation and we talked about software values, I think it was called. So he was a big proponent of like the Node.js ecosystem and had kind of a falling out with them. And he kind of thought about this a lot and decided that like what matters with programming languages is sort of like where they put their values, and that it leads to like a different system. So like Node.js kind of put a lot of importance on just being accessible, like people being able to pick it up. And I think when he wanted some more, thought that there should be some more complex features that would build more robust software, then they were like, well, that would be great, but that would take away from accessibility, right? And I work on Scala, which has a reputation for being very complex, and I think Rust also has, and Haskell.
Yep.
So like, I feel like that's the decision space, like as a language, right? Do you want to be like, do you favor this being an easy language for people to take up? Do you favor that this is a language that's more reliable or more secure? I mean, performance is probably another aspect, but there's all these values, right? And I think languages kind of pick and choose where they fall. Like C++ obviously has some very specific, performance and memory usage constraints on it that will be more important than anything else.
Yeah, that makes sense. Is there in the functional programming landscape, is there sort of a Pareto front there? Like, are there reasons to use Haskell versus Scala that involve, I guess, performance, or is there some speciality that Haskell is like particularly good at?
Yeah. So one thing that is interesting about Haskell is that it is lazy. It has a lazy evaluation model, and I don't know any other languages that have that. So besides all its functional aspects, it has this lazy aspect, which can be challenging, but has benefits in certain cases. Scala, I think, is great when you want to use the JVM, because like you're not going to run into like, hey, like I literally had this problem with Haskell before where I needed to interact with this like SOAP web service, and they're like, yeah, don't do that. Like I think that was their where if you're in Java, like if you're on the JVM, that's never going to be a problem.
Yeah, there's just so many billions of lines of code that have been written.
Yeah, I don't know if that answers your question though.
Yeah, that makes sense. Yeah, I think the lazy evaluation, just to kind of give people more depth on that, because it's supported in it's not part of Python by any means, but if you're using TensorFlow or PyTorch or any of these GPU tensor processing libraries, they're doing lazy evaluation. And what that means is, imagine you have a program that it reads a number from the command line, it adds 4, it doubles it, and then it returns it, right? So it prints it to the screen, let's say. So when you do the add 4 and the double, that doesn't really change. I mean, it changes some memory on your computer, but you don't really notice anything until you do something with that number, like print it. So what a program could do is it could just keep kind of like a ledger of what you said it should do. So you said, oh, you want to, I forgot what I said. I think add 4. You want to add 4? Okay, I'll make a note of that. You want to double this number? Okay, I'll make a note of that. And then when you go to print it to the screen, then it goes back through its ledger and it says, okay, what operations do I need to do? And so, this is a very simple example, but imagine if you did that operation to 2 numbers and only printed one of them. Well, then it doesn't have to do that operation on the other number, which is just going to get thrown away. It only has to do half of the work. That's a big reason to use ledgers, is the pruning, but by far the biggest reason is that there's a lot of latency, especially if you're doing anything on the GPU. Like you have to take information that's on your motherboard, and you have to send it over to this PCI card, right? And that takes time, right? So you can send a ton of information, but it just takes time to get there. And so by batching up all of these commands, you can send 100 commands instead of one command. And even though there might be 100 times as many things to do, again, it's a latency issue, not a bandwidth issue. So you get a huge speed up by doing that. And Haskell has that basically baked into the language.
Yeah, and so Scala has laziness as well, and like a call by name is what they call it, but it's not the default. So it is a very powerful paradigm, as you're saying. Having it as the default, I think that's confusing for people who aren't familiar with it. That is not, you expect a program to work by starting with the first line and then executing through the bottom, whereas you're describing, in a lazy world, it's kind of like it goes all the way to the bottom, building up its computation, and then kind of runs it by backtracking through what it needs to do.
Yep. And so a lot of these languages or platforms will have sort of a immediate mode where, for example, let's say you're developing and you need to know the value. Maybe you have a variable that you're just stepping through with the debugger, but you're not actually even using it. You still need to know kind of at every line of the code what that value is. Maybe just you have all this computation and at the end you get not a number, right? That's really hard to debug. So with immediate mode, you can kind of step through and say, oh, this is the exact line where things kind of went south. So it's totally possible. And so in a way, you kind of get the best of both worlds. You get this immediate mode when you need it, which is a little slower. Think of it as sort of features, which we didn't talk about yet, but we get to. that are resolved right away. And then you also have this lazy mode, which is much faster.
Yeah, and the like I think from like a theoretical CS perspective, like the lazy evaluation mode will always be at worst take as much time as the eager mode, because it can be faster because steps could be deemed unnecessary, but it can have a tremendous memory overhead. Like if you're in Haskell and you want to, maybe they would say just don't do this, but let's say that you were like summing a whole bunch of numbers, but because of the way you did it, it is following kind of the default lazy style, and you're passing around that result number. But the result number, in fact, it's not a memory location of an int. It's actually a giant computation of like add 1 plus 2 plus 3 plus 4. Mm-hmm. So the calculations will end up being the same, but until that's evaluated, they have these kind of space leaks where you end up holding on to a whole bunch of memory without really meaning to.
Yeah, that's a really, really good point. Just in general, these higher order languages will have sort of traps. So I think of it more like you could think of it as like using a machete or using like a chainsaw, right? Like the chainsaw can do a lot more. It can be really quick, but also you kind of have to develop some more skill to use it. And I think that's it's a good way to sort of learn, is to dive in there. You write this program and you realize, oh, why is this taking an hour to run? And then there's a bunch of really good tooling for all of these languages to step through and say, oh, I see why it's happening, because I'm building this huge computation graph of all of this mathematics I'm applying, when really I should at some point just realize all of that computation. I think they call that checkpointing. Should checkpoint the computation so that it collapses that whole call graph, and then you can start again.
Yeah, and what I'm describing is probably like a very much a beginner mistake to not realize that they're chaining around this computation.
Yeah, that makes sense. Yep.
Yeah. What
about
Oh, so by the way, you asked me like, hey, when should you choose which functional programming language? Mm-hmm. So I'm going to say, always choose Scala because that's my favorite.
Nice.
But I think in practicality, like, a language like Haskell or something is a great place to learn about all these FP concepts. But if you need to do real world stuff, like I said, if you need to talk to some SOAP thing or something, the JVM is a good place to be.
Yeah, that makes sense. And if you're at a company or you're doing some software task now in a different language, one thing everyone can take away from this podcast is to realize how to do functional programming in that language. And so just to enumerate a lot of this, if you're in C++, you can use Folly Future. Actually, Patrick, you might know of other alternatives to that. The only one I've ever used is Folly Future. But there's probably 100 other ones that basically give you this async await type paradigm. If you're in Scala or Haskell or something like that, that's very natural. If you're in Java, there's got to be some good libraries, but you're going to be creating a lot of objects. So get ready for a ton of objects. Other language? Oh yeah, if you're doing anything like Node.js, or even if you're doing React or JavaScript in the browser, definitely look at the await async libraries in Node. I think there's RxJS in the browser, but before we enumerate all of them, look up like it would either be reactive programming, functional programming. There's a way to do it in every language. And depending on the task you're trying to do, it could be really powerful. So definitely, dive into that. And it's something really good to understand.
And types, right? If you're doing React stuff, I don't know, maybe TypeScript or Flow or, and another keyword I'd call out is like algebraic data types, which more languages are getting support for, but is a nice way to kind of build data structures.
Yeah, that's one thing that drives me absolutely crazy about TensorFlow and PyTorch is they just have the tensor data type. So if I have a tensor that's, sometimes I've done this where I have a tensor that's, let Let me make sure I get this right. Yeah, okay. So I have a tensor that's, let's say, 5 by 1. So it's a vector, right? And then I multiply by another tensor that's 5 by 1. So what that's going to do is it's going to multiply those two vectors, and that's going to do a dot product. So under the hood, it's going to multiply component-wise, add that all up, and I'll get a single number out. So maybe I do this vector times vector, or this, they're calling it tensor times tensor, and my output is 3, right? But if I get the dimensions wrong, like let's say one of those two vectors is transposed. So now I have a 5 by 1 matrix multiplied by 1 by 5 matrix. Well, what TensorFlow is going to do is it's going to do the outer product. So my result isn't going to be 3 or 10 or 100. It's going to be a 5 by 5 matrix. And nothing warns you about that. So you can just easily get blown up, because sometimes we have these huge vectors and we multiply them together. Maybe it's 1 million items, and we expect them to output a number, but what ends up happening is it outputs this million by million matrix, and it can't even fit that matrix, so your graphics card blows up, right? And it's just that just absolutely drives me crazy. There is something coming out in TensorFlow called named tensors. It's not out yet, but I think to your point, it's moving in the direction of sort of algebraic types. So I think the holy grail there is where you have unit types you can define. Like you could say seconds s equals 10 microseconds, and it would do the conversion automatically, stuff like that.
Yeah. So like a different holy grail is like, if you've actually would encode the size of your matrix into the type. So yep. I've seen this done in a couple languages. So an example in the Idris programming language is actually like he has this function to transpose a matrix, and the way he defines a matrix is it's like matrix, and it has two like type parameters that is like the n by n size, right? So he has a function that takes in a matrix that is size n by m. Maybe those are hard to say over audio. I by j, let's say. Nice. And then it returns it like j by I, right? So by encoding that kind of dimension into the type, you can actually understand that is a transpose function, like without even understanding the body of it, right? You can see just by that these two variables move, that it's actually kind of rotating the matrix.
Yep. Yeah, and if you do, if you multiply these vectors and you set that equal to a floating point number, then the type system could know, okay, there's only certain matrix multiplication operations that can yield just one number, right? And so it would catch that compile time.
Yeah, and your example of, exactly, returning like, instead of a float, some giant matrix. If the type system had that information, it would be a compile time error. You would never even send it off to run.
Yep. Yeah, I'm also a huge fan of TypeScript. The one thing, it was really hard to set up, but to be fair, I was trying to go for the Holy Grail. I did get it eventually, but what I got was, what I wanted was basically the servers and TypeScript running Express. The client was running React, also in TypeScript, and both of them support hot reloading. So what that means is you can edit a source file, hit save, and your server changes underneath. On the client side, every time you hit save, it refreshes the browser and it's up to date. I posted 2 or 3 months ago, from HackerMoon an article on how to do it. It was definitely a lot of work, but it was totally worth it. I think if you're going to build a website, that is the way to go. And as you said, you get the type safety, which is actually really important. It's saved me multiple times.
Yeah, everybody whom I've heard talk about move a large JS code base to TypeScript has talked about like, there was a couple bugs that we didn't know about that it just called out. And like, obviously they're not very prominent bugs because they would have already got to them, but like, if you were developing it in TypeScript, they never would have even been there.
Yep, that's right. And it just helps new people too who are looking at the code base. It's very hard to dive into the middle of a code base and know what's going on. But the type system is really sort of your dictionary that you can kind of carry with you as you're kind of diving through all of the code.
Yeah, I love that. Like, maintainability when you have a lot of types, like, we use types quite extensively in our Scala code bases, probably in ways that would be unusual to people. But like when you can go in and say, I want to move this here, and you kind of can move it and then see what breaks and then slowly, work those changes through, as opposed to like, some Ruby or Python code base where you better have good code coverage and some great reviews. Like the differences are astounding.
So one thing before we jump, I want to jump in and talk about your podcast and other things that you're other things that you're working on. But real quick, how do you keep people from your team from creating like crazy Scala operators? Because I've seen in our code base some unbelievable operators. I honestly thought they were those Animoji, those 5-letter long, like emojis, or they're flipping the table or something. Yeah, how do you keep people from abusing the language?
Well, I guess those are two different questions. We haven't had the operator problem. Maybe that has to do with personal tastes of people on the team. I think that there was like a while where that happened, like in the community of Scala, that it was common to write custom operators for a lot of things. Mm-hmm. And I think that maybe that's not the case anymore. But I also think it's a case where like if you get used to an operator, then you love it. Like you find it easier to understand than a word, but if you're not used to it, it's very confusing. I feel like it's a little bit like Vim. Like I use Vim key bindings and IntelliJ, and like now that I know the bindings and everything, like it's like amazing. But before I knew it, it was like super confusing, and I was like, why would anyone use this?
Yeah, right. I went through the same thing. Being a machine learning person, I know Emacs because that's what they taught us in AI class. But yeah, I remember the first time the professor forced us all to use Emacs. And I was like, what are you doing to us? It's like Control S to search. What's going on? But then over time, you realize not taking your hands off the keyboard is pretty nice.
Yeah, so I think that operators, like it's great that you can do operator overloading. You should only really do it if it's something that's going to be like that. Like you're not going to have to look up what it is. Like if it's going to be muscle memory for your team, like, oh yeah, of course this means combine two lists together and then increment everything by one. I don't know.
Yeah, that's right. Yeah. I think and then one thing that trips people up too is the underscore for arguments that don't matter. Because like if you see, so just to give people some context, if you have a function and let me make sure I get this right. Function takes sort of, let's say, 2 arguments, but the first argument you're not using, you could put an underscore just to say, hey, I know there's supposed to be something here, but it's irrelevant, instead of putting the word dummy or something like that. But then what can happen is you can end up with like open paren underscore plus underscore close paren, and people look at that and think that that's one whole operator, right?
Yeah, which ties into your other question, right? Like how do you... Like Scala is a very flexible language. Mm-hmm. And then so how do you restrict, what people do? Because you can do more than that with underscore, because you can refer to it, right? So you could have a function that is like bracket underscore comma underscore bracket and then like arrow and then underscore dot one and underscore dot two.
Yeah,
like,
that's right.
I mean, so I think that is a harder question, right? Like how do you... I think the same is probably true of C++ to an even greater extent. Like the language is so large, you have to kind of, as a team, reach kind of some sort of consensus. Yep. But in Scala, like we use linters and code formatters and kind of enforce things in the build. And that's great. Like something like instead of arguing about code formatting, like in PRs, we have a config that kind of dictates what our code formatting will look like. And if you want to argue about it, you could just make a change to that and then argue in that PR where it reformats everything to the new standard, which is just great at removing the diversion of arguing about code formatting.
Yeah, I remember the days of people arguing over spaces and things like that. It was just unbelievable. And now, even C++, every language has some type of way to automatically format. And that takes so many of these arguments off the table. It's like, if you don't like the formatting, you could even reformat the whole code base and then just format it back when you go submit your PR. I mean, if you're that into it. Yeah, I agree with you. I think some of the more semantic things are just handled in the peer review. So we have this sort of meme we call Clown Town. And so I think it comes from The Simpsons, but I don't watch The Simpsons, so someone will have to correct me on that. But yeah, there's basically this emoji we have of Krusty the Clown, and so yeah, when something's getting kind of clowny, we put Krusty on it. So if someone has a pound define that creates a class in C++, they get Krusty, and that's the way we sort of enforce it.
We have a bike shed emoji for when people start fighting about dumb things.
Oh, really? Wait, what is a bike shed? I don't even know.
I think it goes back to this old story that says, like, that they were building a nuclear reactor and they had a committee to like oversee all the plans. And then the committee spent all their time arguing about the color of the bike shed because like the idea was that the people on the committee didn't know anything about nuclear reactors, but they understood bike sheds. So they're like, that's what they focused in on and argued about. It's kind of like you're focusing on the wrong thing here.
Yeah, that's amazing. I noticed that it takes a certain personality to invent an entire framework or library or even programming language. And so you have to be sufficiently dissatisfied with the status quo, right? Mm-hmm. And so when you get a lot of programming language inventors or platform inventors together, you end up with a lot of contrarian opinions. And then, I think I need to borrow that bike shed emoji.
Yeah, it's true. You can have too many divas, or I don't know what the right word is.
Yeah. So tell us about your podcast. So it's Co-Recursive. Is it purely recursive programming, or is it more general? What's the sort of topic?
So it is not purely about recursion. So the show is an interview format, and so it is a software development podcast. And if I'm curious about a subject, say, similar to this episode, or if I want to know about TensorFlow or some new programming language, I find an expert in that area and bring them on and kind of have them explain that area to me, and I ask questions, and I'm hopefully not afraid to say, like, I don't understand. Could you explain that again? And so that is the format. It's kind of a deep dive onto a technical area, an interview at a time. There's been a lot of shows on areas of functional programming, shows on building your own programming language, shows on Rust, incident response, kind of a wide swath of topics. But
cool.
I just picked the name because a co-recursive function is something that kind of produces a stream of values. So it's kind of like a pun in that I'm producing a stream of episodes. But,
all right.
But really,
nice.
It's just a name that's distinctive.
So what inspired you to get into podcasting?
So I was listening to a lot of tech podcasts, and I thought that there was certain topics that I would love to have covered that I didn't really see being covered. And originally I reached out to this podcast, SE Daily, to see if he would cover some of these topics. And he said, well, why don't you try like just doing guest hosting for the show? And I did that once or twice, and then I just found that it's a lot of fun. Like I like to be able to talk to people about software, and so can't stop now.
Cool, that's awesome. Well, I'll have to make you a trade, and I can come on your show if you want to talk about any machine learning stuff.
That would be awesome.
Cool. And can people catch you on like what sort of social media are you most prevalent on?
Yeah, so definitely, check out the podcast at corecursive.com. If you, Google Adam Gordon Bell, you'll find me. I'm on Twitter at Adam Gordon Bell, and also at corecursive. And
Cool. So if people want to reach out to you, do you support DMs on Twitter, or should they email you through the website? How can people get a hold of you?
Yeah, you can DM me through Twitter. You can email me, adam@corecursive.com. And check out the podcast. I think it's super interesting. If you liked this episode and you need more podcasts, I think it's probably a good fit.
Cool. Yeah, I mean, we get a lot of people saying, "Hey, why don't you do more episodes?" But I think that there's a lot of really good producers out there creating a lot of great content, and Patrick and I also have a lot of kids, so I think we'll stick to one episode a month. And yeah, if you're interested in knowing more about really a lot of these topics that that we're all interested in, but especially recursion, functional programming, things like that. Adam does this literally every day. He's very passionate about it. And you should check out his podcast and hit him up on Twitter. All right. So thanks a lot for coming on the show, Adam. I really appreciate it. This is an awesome episode. I think we really dove deep on functional programming. If people still have questions, don't hesitate to email us. You can also ping Adam. You can email both of us. But I think hopefully we cleared up a lot of the mystery around functional programming, because it is something that's really difficult to dive into.
Yeah, this was a lot of fun. Thank you so much.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.